question number 66, which says that which of the following is isostructural with BeCl2. So first of all, draw the structure for BeCl2. So students, you must be knowing that BeCl2 is linear. So it is linear and it has 2 sigma bonds, so hybridization will be sp. So now if I talk about NO2, so the structure of NO2 is bent. So this is the structure for NO2. Now we have SnCl2. So SnCl2 is also bent. And now we have SO2. And SO2 is also bent. So now we have fourth option, that is C3O2, which is also known as the carbon sub oxide. So this is a very special molecule. So this is the structure for carbon sub oxide, that is C3O2, where the hybridization of each carbon atom is sp and the shape is linear. So we can say that the beryllium chloride and C3O2 are isostructural. So option number 4 will be the correct answer. Now moving on to the next one, we have question number 67. So in which we have to identify the equivalent weight of the complex, that was FeCN6 4 negative. So first of all, write down the reaction FeCN6 4 negative, which is being converted into Fe3 plus CO2 plus NO3 minus. So इस reaction का equivalent weight निकालने से पहले we have to find out the N factor. So first of all, calculate the oxidation state of each atom involved in the reaction. So अगर हम first compound में देखते हैं, which is the complex, suppose the oxidation state of iron is X. So X minus 6 is equal to minus 4. तो iron की oxidation state कितनी हो जाएगी? Plus 2. So we have iron is in the plus 2 oxidation state and it is converting into iron plus 3. So we have here the cyanide. So cyanide में carbon की oxidation state होती है plus 2. और ये plus 2 से it is converting into plus 4 in carbon dioxide. अब nitrogen की oxidation state in cyanide is minus 3 and which is converting into plus 5 in NO3 negative. So you can see here in the complex, each of the atom is undergoing oxidation. So write down the separate reactions. Iron plus 2 is converting into iron plus 3. So कितने का loss हुआ? 1 electron. So this is my first part. Now in the complex we have 6 carbon atoms. So I can write it like this, C6, and it is in plus 2 oxidation state and it is converting into CO2 plus 4. तो each carbon atom के लिए कितने electrons का loss हुआ? 2, और 6 carbon atoms के लिए कितना हो जाएगा? It will be 12. तो यहाँ पे हो जाएगा 12 electrons. So this is my second part. So let's talk about the nitrogen. तो nitrogen में कितने हैं? There are 6 nitrogens and it is in minus 3 oxidation state. अब यहाँ पे it is converting into NO3 negative and where nitrogen is in plus 5. So the loss of 8 electrons is being done in this case for one nitrogen atom. But here there are 6, तो कितने हो जाएंगे? 6 into 8 is equal to 48 electrons. So each atom is undergoing oxidation. So total N factor will be the sum of all the parts, that is 1 plus 12 plus 48. तो हो जाएगा total electron loss is 61 per mole of the complex. So we can say that n factor is 61. So the equivalent weight will be equal to molar weight divided by n factor. So that is m by 61. So option number 3 will be the correct answer. So moving on to the next one, we have question number 68. So two-dimensional sheet silicates are represented as. So these are all the general formulas for all the silicates. So in the first case we have Si2O76 negative, so which is the general formula for pyrosilicates. And in the second one we have SiO4 4 minus, which is the discrete tetrahedral unit. So it is the formula for orthosilicate. And now you have SiO3 N to N negative, and it is the formula for cyclic silicates. And in the fourth option we have Si2O5 N to N negative. So it is the formula for sheet silicates. So our option number 4 will be the correct answer. So moving on to the next one, you have question number 69. So in this case, we have to find out the correct options among the following. So in the first case, we have lithium can form lithium nitride. So the only alkali metal which can form nitride by combining with nitrogen at high temperature is lithium. So this is the correct statement. Now we have the second statement in which we have the order of various carbonates of alkali metals, and we have to find out the thermal stability order. So carbonates of alkali metals, the thermal stability, we can say that it is directly proportional to the cationic size. So जितना ज़्यादा cation का size होगा उतनी ही ज़्यादा क्या होगी thermal stability. And you know that as we move down the group, the cationic size increases. So cesium plus has the largest ionic size. So the cesium carbonate will have the highest thermal stability. So this order is absolutely correct order. Now we have the third statement, that is lithium Cl is soluble in pyridine. So that is absolutely correct statement. So this is correct. Now we have the fourth, that is calcium hydride. It is known as the hydrolith. So this is the under name of the calcium hydride, that is the hydrolith. So this is also the correct statement. So we have all the statements correct. So option number 4 will be the correct answer. So moving on to the next one, you have question number 70, which says that the mole of FeSO4 required to be oxidized by 1 mole of potassium dichromate in acidic medium. So first of all, write down the reaction of ferrous sulfate with potassium dichromate. So we have ferrous sulfate and potassium dichromate. So you very well know that in acidic medium, the dichromate is converting into chromium 3+. And it is an oxidizing agent, so it will oxidize iron 2+ to iron 3+. So we can individually write down the reactions to balance the equation. So first of all, we will do for the oxidation part, that is iron +2 is being converting into iron 3+. So यहाँ पे कितने इलेक्ट्रॉन का चेंज है, that is 1. Similarly do it for dichromate. So in dichromate, so we have chromium in the +6 oxidation state. So now it is being converting into +3 oxidation state. अब balancing number of chromium atoms, there are 2. तो एक chromium के लिए कितना change हुआ, 3 electrons का change, and 2 chromium के लिए कितना change हो जाएगा, 6 electrons. So here it will be 6 electrons. So now balance the charge here. Add 14 H plus to balance the charge. Now add the water molecules. So it will be 7 H2O. Fine. So to balance the change in electron, multiply the first equation by 6 and add the two equations. So the final equation will become 6Fe2 plus Cr2O7 2 negative plus 14H plus giving 6Fe3 plus 2 chromium 3 plus 7H2O. So this is the final balance equation. So now we have to identify the mole of FeSO4 required to be oxidized by 1 mole of potassium dichromate. So you can see here 1 mole of potassium dichromate is oxidizing 6 mole of ferrous sulfate. So option number 3 will be the correct answer. So moving on to the next one.